Trash. Oh, that's the one. Hello, how's everyone doing today? Okay, let's get started. Where'd everybody go? There we go. I lost you for a minute. All right. We are going to share screen. Hold on. As soon as I can get this thing open. Yeah. All right. So last time we looked at types of compounds and types of reactions and their products, basically. And that was pretty much it. I mean, that's all we need to know. Now, there's a PowerPoint right here that I was telling you that it's a really good one. If you want to look at it, it's got some pointers on what to look for, but I kind of gave you those pointers already. And there is no recorded lecture because this was in person. We are, however, recording this one, and we're going to move on to molds. So the very first thing we're going to look at is stoichiometry. To do stoichiometry, this PowerPoint is actually more like a figure that I made, is that you can imagine that there is no other way to go anywhere other than the way that I'm telling you. Okay, so hold on, let me download this. There it goes. No, not that one. Oh, is it back to doing this stuff? No, 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 no. That's not what I want. There we go. Okay. Okay. It's doing the wrong thing, but this time it had it. All right. So stoichiometry is used by chemists to figure out what quantity they're going to produce by using a certain amount of reactants. That's how they know, like not electrical, but chemical engineers use this kind of thing in mass. So, oops, sorry. So with that in mind, just think of the way that you convert from moles to grams and grams to moles is using the molar mass, right? So in this case, what we're going to look at is how that molar mass goes from one place to the other. Okay, so let's say you are going to convert this. Okay, so if you are traveling from one island to the other, there's only one road, right? The path is full of sharks if you swim across, so you can't do that. You can't jump across because there's no way to go across without going through one of them. So that's the point, that you're going to have to go. Let's say you're in moles of X island, so you already know how many moles we have, but you want to know how many grams of Y you're going to produce. Then you start with moles of X, change it to moles of Y, and this is your connecting road. You see that? The mole ratio of X to Y from the balanced equation, okay? And then from moles of Y to grams of Y, you would use the molar mass of Y. Let's say you start from grams of X, but all you want to know is moles of Y. Well, you're going from grams of X, you convert it to moles of X by using the molar mass of X, and moles of X to moles of Y by using the balanced equation. And yes, it is necessary to always have a balanced equation. That's why we needed to look at how to balance first. And also the type of reactions also helps you to balance. That's also part of it. All right, so that's it for that particular approach into stoichiometry. Now, there are other things that you can look at, and we're going to look at the molar mass conversion, mole conversions. And for that, we have this other little, I think this is it right here. It's another diagram that's also very beneficial for you, because it pretty much gives you the same kind of thing. It's a path that you need to go to get there. Okay. And yeah, this is it. So let me download it, make sure that that's the right one. This one's gonna open because it's okay. It's a Microsoft document, it's fine. All right, so for this one, what you want to look at is what they're asking you for. Okay, so we are pretty much limited to the yellow brick road, basically the blue and green road that we're not doing until CHEM 2. So mass in grams, you use the molar mass to get to moles. And remember, everything starts with moles. You see that? Moles is a central, the central concept that you have to go to so that you can convert into something else. So looking at that, you can see that from grams to moles, you need the molar mass. And from moles to number of particles, you need Avogadro's number, which is right here. Okay. Now, if you were going the other way, if you were going from moles to liters of gas at STP, you would use the molar volume. And moles to liters of solution, you would use molarity. But that's for another time. Anyway, so just remember, we're following just the yellow part. Okay, so just the yellow brick road, the yellow and gold right here. All right, so keep that in mind, and we're going to do some problems. Conversion only. We're just going to do mole conversions first. Now, do you know how to do molar mass? That's the main thing. If you don't, we need to learn how to do that. If you don't know, oops, gas laws. No, I didn't put gas laws in because I didn't think we needed it yet. All right, so molar mass. I'm not seeing molar mass. Where's my molar mass? Oh, we did molar mass. That's right. We did molar mass already. It's up here somewhere, didn't it? Yeah, we did that molar mass. Where did we do you? But it was up here somewhere. I remember I put it up here so that we would have it. Come on, molar mass. Anyway, we've done it. If you don't remember, you'll remember as soon as I'm doing a few of them anyway. Oh, there it is right there. Molar mass calculations. It was even an assignment. Just due in April 11th, as you can see. So make sure you do these 2 assignments, okay? So with that in mind, we're moving on to the balanced chemical equations, which is not open yet, but I'm going to open it now since we've already covered it. Let me give you a, no, that's, oh wait, yeah, we're definitely doing that. That's the assignment. For that one, here we go. It's going to be due, let's say the 15th, because we're opening it today. But it's going to be open until May. Is it May? No, it's at the end of April. That's what I've got it doing. Yeah. Okay. But it's available today. So the 8th. Okay. There we go. That should do it. No, add nothing. Sorry. Wrong one. I meant to say save. Okay. There we go. So now we've got that on there. Make sure you guys do it. All right. Next, we are going to look at what we were going to look at, which is more conversions. That's our next thing. Okay, oops, one more. I'm not going to modules because then I got to go through a lot of stuff before I get there. So I just go this way. And it brings me to it. Okay. All right, so there we go. So we're going to do more conversions, a few of them. We're going to look at stoichiometry also. But first, we're going to do more conversions because you guys need that practice. Did you all do the assignment yet or not? No? Okay. So let's see. More conversions. We are going to convert just a few, just some that you are going to like to do. Okay, so we're going to convert from moles to mass. Okay. So moles to mass. The very first question, and I'm going to go ahead and do a different share so that we can go to the board and share that. I'm going to put the text in first. Okay. So it says you want to convert. You want to know what 0.625 moles of oh, sorry, no, that's a different one. Let's start with the other one first because we want to go for mass first. 848 grams of copper wire has how many moles? And I'm just gonna, write the question because I'm having to do that. All right, so how many moles are there in 848 grams of copper wire? Okay, so how we start is we always start with what we know. Remember, I've always told you that. So you put 848 grams of copper. Molar mass of copper is in your periodic table. So just look at your periodic table and see how much 1 gram of copper, 1 mole of copper weighs is 63.55 grams. Copper is equal to 1 mole of copper, right? Okay, so grams of copper would cancel and we get moles. And all we have to do is divide 848 and what's your sig figs? Divided by 63.55. And that gives me 13.3 moles. That's what you got? That is correct. Okay, that was going from grams, right, to moles. We used molar mass right here, right? Right, that's one. Let's do another one. We are now looking at the one that I was typing in earlier, but we want to start with the mass first. 0.625 moles of calcium. Okay, how many grams is it, right? Oops. How many grams? Okay, that's our question. Many. Oh Lord, my fingers are not pushing hard enough on this. All right, so how many grams is it? We're going to do that. To do that, we're going to start with what we know. What we know is 0.625 moles. All right, so we say, oops, sorry, wrong one. We say 0.625 moles of calcium is what we have. For every mole of calcium, right, moles has to go on the bottom so we can cancel. And on the periodic table, it says it's 40.08 grams of calcium. See? All right, so what we need to do is multiply this time. So we have 0.625 times 40.08. And watch the sig fig, since we only had 3, is 25.0 or 25. Actually, I get 25.05, so 25.1, right? Grams of calcium. That's our answer. Once again, we went from grams to moles, right? Oh, no, sorry, the opposite. Moles to grams this time. But we still use the molar mass. You just got to pay attention which way to put it. You notice this time we multiplied, last time we divided. That's because the units are telling us what to do. All right, now we have another question. Now this one is asking us to take a certain number of moles. So it says, how many molecules are in 2.25 moles? Okay, that's what we have. And they want to know how many molecules of what? Hold on. Bromine. And bromine, remember, is diatomic. So how many molecules? Okay. Molecules. I'm just put molecule. All right. So to start, we know how many we have, right? Always. And we know it's bromine. You notice it didn't say atoms. Okay. So 1 mole of bromine 2 has 6.02 times 10 to the 23rd molecules of bromine 2. Once again, moles will cancel, and molecules is what we want. Okay. So when we do this, we're multiplying, right? So we got 6.02 second EE 23 times 2.25. And 2.25 is the one that dictates our sig fig. So it's 1.35 times 10 to the 24th. And that would be molecules, right? And it's called molecule of BrO2, sorry, Br2, there, like that. All right, so this time we wanted to go from moles to molecules. And we used Avogadro's number. I just call it Avo number because I don't have enough room. But there. Okay, so see how each time we're using that bridge that I showed you earlier? Okay, next one that we have is another style like that one. All right, we have a question and it says, how many moles? So they want to know how many moles. Oh, you know what? I was doing this in text. That's why I was like, what? Okay, how many moles in hold on. I lost myself. 2.88 times 10 to the 23rd, 10 to the 23rd molecules of, and the of is sodium bromide, so NaBr. Okay. So for this one, we start with what we know once again. And what we know is 2.88 times 10 to the 23rd molecules of NaBr. And we know that for every 1 mole, right, of NaBr, we have 6.02 times 10 to the 23rd molecules of NaBr. And you notice again, we can cancel molecules and we have that's what we want. All right, so we're dividing this time. So we're doing 2.88 divided times 10 to the 23rd divided by 6.02. And that's going to give us the answer. And we need 3 sig figs, so 0.478 moles of, and this is moles of NaBr. And once again, we went from molecules, right, to moles, and we used Avogadro's number here. Okay. All right, So now let's do one that goes all the way across. Okay. Let's do that one. What would we do? Okay. Hold on, I'm getting there. Okay, so we have 4.77 grams of lead. And they want to know how many molecules this is. Okay. Right, so what do? We take what we know, and we first have to convert to moles. Remember, I told you moles is the central part. So we always got to convert to moles before we can convert to anything else. So 1 mole of lead is equal to, let's look at our periodic table, and it says 207.2 grams. But we don't just want moles of lead, so we need to keep going. Now, 1 mole of lead, again, is going to give us 6.02 times 10 to the 23rd. That's a 2. 23rd molecules of lead, or atoms in this case, but okay. All right, so when we multiply in the top 2 numbers and we're dividing it by the bottom. So it's 4.77 times 6.02 second EE23 equals, and then you divide it by 207.2. And the answer is going to be in, and look, grams of lead cancel, moles of lead cancel, and we end up with what they asked us. Okay, so the answer always had 3 suffix, so it's going to be 1.39 times 10 to the 22nd molecules. In this, really, this is atoms, so I shouldn't have put molecules, atoms of lead, because this is a single thing. All right, so there you go. So the answer is right there. It's 3858, so it's 38. All right, and there you go. That's the answer. So this time we went from grams to moles to particles, right? Or atoms in this case. I put molecules, but it's atoms. Here we used the molar mass, the molar mass, which is from the periodic table, and here we used Avogadro's number. Right, let's do another one. This time you guys are going to do it. All right, so I have okay. This one's an interesting one. Let's see if you guys can figure this one out. Right. It says, I'll type it in. All right. Start already. Okay. It says at 4 degrees Celsius, water has a density of 1.000 grams per liter. Okay. How many moles of water are in 1 kilogram of water, of course. Okay. Try that one. And then a second question is how many molecules of water is that? Are there in 1 kilogram? Okay. We have 2 questions to answer. Okay, so you can pass the page. And what's your sig figs, by the way? Oh, and I should have said 1 point. This is where I messed up. There we go. Oops. There we go. That should have been like that because we're watching sig figs, so we need 4. All right, let me know when you got it. Let me know when you are done by just putting the answers to both in the chat, please. And I want you all to answer it. Okay, is anyone having any luck or any success doing this? Be honest. I'm going to bring you back to the conversion diagram because it doesn't look like you guys are getting this. So let me go get it. Okay. All right. I'm going to remind you what you need to do since it doesn't seem anyone's having a good look. Okay, so we're going to share this. Okay. All right. So remember how this worked. When you're going from grams, which we have 1 kilogram, right, to moles, what is it we need? See, the molar mass. When we have moles, once you have the moles, then you want the number of particles, then you need Avogadro's number. So you see that? You first got to calculate the molar mass of water. Otherwise, you're never going to get this. And yes, you definitely need to convert kilograms to grams in order to use molar mass because it's grams per mole, right? So there you go. Oh, wait. Yes. All right. So I'm going to bring you back to the old screen. Or do you want me to leave it here so you can be looking? Do a thumbs up if you want me to leave it here. Thumbs down if you don't. Thumbs up, thumbs down. No, no. Okay. You guys are getting, or one of you at least, I don't know if all of you are getting the same thinking, but it's not correct. Okay. Um, okay. All right. Excuse me. Yes, you don't care one way or another. Well, I was gonna leave it here, I guess, since you are looking at this stuff. Remember, look, it's right here. The answer is right here in front of you. The mass in grams, you need the molar mass of whatever the mass in grams is, right? That they're asking you about to get to moles. So what are they asking you about? Okay, so let's annotate so that you guys are getting confused. This is a pretty straightforward thing. Just got to remember, we have one, okay, so right here, in this area, right here, right? We have 1 kilogram, right? We need to convert of water, right? Of H2O. So we need to convert it to moles. So we need this. What is the molar mass of water? Remember how to calculate molar mass? We did it earlier. We look at the periodic table. It is H2O. So it's going to be 2 times 1.01 plus only one of those, so 16.00. The answer is 18.02 grams of water per mole of water. And there you go. That's what you have to use. So you're thinking, because the density is 1 gram per milliliter, has nothing to do with moles. Okay. They just gave you that. You didn't really need it. Now, if they had asked you how much would it be in 1 liter of water, then yes, you would have had to convert. But in this case, they gave you kilograms. So you didn't, all you had to do is change kilograms to grams because of that, right? So that's your first step. And then once you have moles of water, then you can use Avogadro's number to convert to number of particles. Okay. So let's see if you guys get that now. Nope. Okay. All right. I know. All right. Let me show you guys how to do this. Okay. One last time. And pay attention to all the steps because there are a lot of steps. Well, not a lot, just 3, but you still need them. All right. We're going back to the whiteboard. All right. So the question is, the very first thing to do is to convert 1 kilogram to gram, right? So we got 1.0000 kilograms, right? That's a point. We say 1 kilogram is equal to 1 times 10 to the third grams, right? So now we have just converted to grams. The next thing that they're asking us is how many moles that is. And this is water. So this is all H2O, right? We know that part. Oh, hold on a minute. Okay. Oh, sorry, that got in my way. All right, there we go. Okay, so this is H2O. All right. So since this is H2O, we need the molar mass of water, like I was showing you. So H2O, you have 1.01 from hydrogen, but there are 2 of them, so that's 2.02, right? And then you've got 16, and there's only 1 of those, so 16 grams from hydrogen, from oxygen. You find these by looking at one thing specifically, and that is the periodic table. And that gives you 18.02 grams per mole of water. So grams is up here, we need grams down here. So we need to put 18.02 here, right? And 1 mole here. And we know this is all about water, so we're not gonna write water every time. All right, so once we have this answer, that's our first answer, how many moles there are. Okay, the first question asks you how many moles. The answer, when you do it, if you stopped here, would be 55.49 moles, right? Okay, that would be the answer. But they asked you also how many molecules that would be. Okay, so 1 mole goes down here again, and now Avogadro's number comes into play. Okay, so once you do all of that, if you multiply the top, the bottom, and like I said, you can stop at any point just to get the first answer, but the first answer is going to be 1,000, right? Because it's 1 times 10 to the divided by 18.02. That gives you 55.49. That's the first one. And then the next part is just multiplying it times 6.02. Second e to the 23rd. And that gives me the answer to be 3.34. And we need 3.341, because we need all 4 sig figs times 10 to the 25th, sorry, molecules. Okay, of water, of H2O. We know everything here is about water, but that's how you do it. So make sure that you go through all the steps. That's why this diagram is very, very, very helpful, I think. Let me share that with you again. Let me see here. Okay, we're stopping that share and we're doing a new share. Oh, everybody else left. Okay, so let's do a new share. And this diagram right here told you exactly what to do. See how I told you you need the mass in grams. So the grams, we had kilograms, so you knew you needed to change that. So that should have been your first step. Hold on. So let me do an annotation thing here. Okay. So you had 1.000 kilograms right here. Sorry, my little vacuum cleaner's over here trying to clean me out. Okay, so that you change to grams, right? From grams, you use the molar mass, which was 18.02 grams per mole. And that right there tells you how to use it. You went to moles, so mole needed to be on top. So that means this was a division. And then from moles, you went to particles. So you here, you got your moles, which was 55.49, right? Right here is where we stopped and we got this answer. And then we multiplied it. This time we multiplied it because this was moles already. So we needed to put moles on the bottom. So we multiplied times this, right? This was divided by this, right? And we got the number of particles, which happened to be 3.341 times 10, 1 times 10 to the 25th. See? So all of this is right here. We did every single thing just right. Of course, sometimes you have an extra step before it, but it just depends on what it is. What if it had been 500 milliliters of water? Okay, then you would have transferred that into 500 grams of water because it's 1 gram per milliliter, right? So that's the point of this, that you are always going to be able to use this little construct right here, this little graphic organizer, I guess you could call it. It's a path that's showing you how to go. All right, so let's clear all of that and try to do those small conversion problems. Let me see. You can always download them even though they're not ready yet. I mean, I haven't opened them yet. Let me stop this share and do a new share. Okay, so on this one, I have this share. Hold on. Yeah, not there. This. Okay, so right here. See, you got mole conversions, but that's just that. But there's the assignment. You see that? So you can look at it actually. You can look at that mole conversions document. And there they are. And you've got a percent composition question, which I will be also showing you. This is why I didn't do this, because we're not there yet, right? We didn't finish. So I didn't assign this to you yet. But you can look at it and see how to calculate everything. Like right here, for example, we're going from grams and they want to know number of particles. Okay, so you use Avogadro's number, but you got to go to moles first. So grams, molar mass of platinum, and then Avogadro's number. Same here. In this case is the opposite. You have particles, so you're going to Avogadro's number, that gives you moles, and then molar mass of mercury in this case to get there, and so on and so forth. This number 5 is going to give you a little bit of a challenge. The other ones are easy. And then the percent composition, don't worry about it just yet, but we will do that shortly, and it's no big deal. But then we're going to have actual stoichiometry problems. This is just the conversions. All right, so that is all for today. You have a wonderful weekend. And I will talk to you, I will talk to you next time.
Alrighty then.
All righty, take care, man. Bye-bye.